This is the second half of the lecture for Chapter 5. We're going to pick up talking about spectrograms. It gives a visual representation of a sound, and it shows the components, the frequency, the time, and the intensity. We're going to look at a lot of spectrograms at the end of this. Formant and vowel quality. Only periodic sounds show formants. So those wave patterns, it has to be a periodic wave to show formants. Formants are crucial in distinguishing various sounds, and different vowels are identified by different formant patterns. In your book on page 62, it actually lists all the sounds and all the formants for American English, and this does vary according to dialect, but this is a study that was done to really figure out formants. You notice F1 goes up and then it comes back down. F2 is coming down and keeps coming down. And we're going to talk about why that is. Formants and vowel qualities. The first three formants are the important thing of what we look at. The remaining formants are helpful for looking at other characteristics, but we really focus on the first three. If F1 is inversely related to tongue height, so if you have a high tongue, like in E, you have a low first formant, which is actually on this chart 280. If you have a low tongue, you have a high F1, which is like ah, which is actually about 690. F2 is related to the blackness of the backness of the vowel, not the blackness. If you have a front vowel, it has a high F2, like E. It says 2320. That's really high for a front vowel. If you have a back vowel, like oo, you have a low F2, which is on this chart 720. The numbers aren't as important as you knowing the patterns of the formants and what happens as your tongue moves through your mouth. Formants and vowel qualities. F1 and F2 are further apart. Think about it. What do you have? What kind of vowel do you have? You have a high front vowel. If you have an F1 and F2 that are closer together, you actually have a high back vowel. So think about those in according to the relationships that you see. Diphthongs are vowels that change quality during the articulation. So what do you see on a spectrogram? In the lecture handout, you actually can see A, O, E, O, Oi. So you can see those, and you can see how the F1 and the F2 changes on each of these as the vowel changes. Formants and vowel qualities. F3 is related to rhoticization, which is the rounding. So if you think about it, there's going to be different formats for light and dark L, for W, and formats for Y, which actually would be a low F1 and a high F2 if you think about Y in your mouth. Here's actually a picture of liquids and glides. So we have lead, red, wed, yet, yell. And so you have to look at the formants. You can tell what happens. The vowels take on, or the liquids take on the shape of what the vowel is around it. So you can kind of see the differences within that, how they change. This is actually weather, a spectrogram, probably taken from Pratt, of weather. Now, this is voiced, so I'm surprised there's not more sound right here, but you can definitely see where the w happens, the th, and the and you can see the different formats that it goes up. That second format goes up as it goes along to the F. Nasals look very similar to the vowels next to them, as well as the liquids. So if you look at these, you can see the differences between them. So the takes on the look that is around it. The a, n, and the an. You can see the differences on the spectrogram, how that changes. So stops, there's actually a gap in the spectrogram between the abrupt onset and then the release, which actually is measured as the aspiration. And another thing that we're going to talk about is voice onset time. So if you have a stop and then a vowel following it, like pa, you're going to have the air stops and you're going to see a gap, and then you're going to see where the vowel starts. But there's actually a little bit of time between when you release that sound and when your voice actually turns on, and we call that voice onset time. So this is beat, b, eat. And you can see the difference. And you can see the time that it takes to kind of warm your voice up and get it started. And there's the E. You can see format 1, format 2, format 3. Fricatives, as we talked about, are obstruents, which are more aperiodic waves. And you can see that in spectrograms. And it looks more like random noise. And on these spectrograms, you can see it more here for the S and here for the sh. If you notice, there's no regular patterns in the sound. You can't pick out the formants like you can with the a, fe, tha, sa, sha. You can see the formants, and you can see the voice onset time here. Takes a little bit for the voice to turn on. Affricates is going to be the same thing, but what do you expect? It's a stop plus a fricative. So you're going to have the characteristic of a stop and then that affricate or that aperiodic wave that shows up. So cheese. On your own, can you tell where cheese is? Ch, ch. This is all ch, e, z. So you can see the stop in it. You can see the fricative. So it's a stop plus a fricative is an affricate. And then you can see these. Look at how wide these formants are because of the E sound. And then you have the Z, which is more random. So what do you think taps would look like? If it's kind of in between a T and a D, you kind of have your voice on, but not really. So this is better. And you tap on better. We usually don't say better. So we have the B, E, the tap, and then the So you can kind of see the difference there. If we have voicing, voicing shows energy from the vocal folds or vibrations. Look for a voicing bar. So where's the voicing bar? This is S and Z, and this is T and B. So if you look at it, there's a little bit of voicing in the T. It shows up. I'm not quite sure why. But here's the voicing bar. It's really clear, and you can see those formants showing up in voiced stops.